Alright guys, welcome to your Unit 6 Study Guide help video. In this video here, I'm going to go ahead and go through the odd problems and let you guys handle the rest of them there, okay? So first thing you guys want to know how to do on this exam is how to multiply polynomials out. And so when you're multiplying, the first thing you want to do is you want to start by looking for your shortcuts first. And so here's a shortcut that we've talked about. If you multiply that, you get x squared minus 9. You get that by just doing first times first and last times last. And then this is another shortcut. For that one, that x plus 2 squared, that really means we're doing x plus 2 times x plus 2. And so whenever they're exactly the same, we still do first times first, and we still do last times last. But we also do the middle ones multiplied together and then double it. And so that one's going to become x squared plus 4x plus 4. So we always start off with our shortcuts. The next thing we do after that is we're going to do the box method. So that's going to apply to these two polynomials here. So I've got a trinomial and a binomial, which means my box needs to be 3 by 2. My trinomial will go up here, and my binomial will go down the side here. And then we multiply to fill in the box. So when you multiply to fill in the box, you're going to have x to the 4th, 4x to the 3rd, 4x squared, here we'll have negative 9x squared, negative 36x, and then finally negative 36. And then you're going to take all these terms that we have put into the box out of the box, starting with the one with the highest power. And then the next one would be a cube, so I'll take out my cube there. And then my next power would be the squares, and I've got 2 of those, so I'm just going to combine those now. So I'm going to add those together by doing negative 9 plus 4, which would give me negative 5x squared. Then my last one there is going to be negative 36x and minus 36, last one there. After you've done your box method, the last thing you're going to do is you're going to do the distribution. And that's when you just take that little monomial there and you multiply it to the inside of your parentheses. So it's going to be negative 3x to the 5th minus 12x to the 4th plus 15x to the 3rd plus, I want to say 108 for that. And that's multiplying polynomials. All right. All right, let's move on to our next one there. I'm going to leave number 2 for you, but I'll go ahead and do a long division problem for you here on number 3. So when you're doing long division, your divisor goes outside of the division bracket. Your dividend goes inside. Now when you put this thing inside, you have to make sure that every term is accounted for. Since I don't have an x squared term, I need to put an x squared term in there with a 0 in front of it. You have to do that also for your dividend, but in this case, we're not missing any terms, so it's unnecessary. Now, we do our long division, and we just ask ourselves how many times does 3x squared go into 15x to the 4th? And I'll show my work this one time off to the side, so I just take 15x to the 4th, and I'm going to divide it by 3x squared. 3 goes into 15 5 times, and x squared goes into x to the 4th, x squared times. And so that one's going to be 5x squared. Then you're going to take that number there, and you're going to multiply it by all 3 of these numbers, and then you're going to write your answer down here, and you're done. So let's do that. 5x squared times 3x squared is going to be 15x to the 4th. 5x squared times negative x is going to be negative 5x cubed. And 5x squared times negative 4 is going to be negative 20x squared. And then we're going to subtract this whole thing, which means we're going to go through and change all the signs. And then you're going to combine the like terms together. These two will cancel. Negative 29 and positive 5 makes negative 24x cubed. And then 0 and 20 makes 20x squared. And then we just bring down the next term. And we repeat the process. So now I ask myself, how many times does 3x squared go into negative 24x cubed? 3 goes into negative 24 negative 8 times, and x squared goes into x cubed x times. And then I'm going to multiply my 8x times all three of those and put my answer here. So let's do that. And we're going to go through and change all these signs on the bottom because we're subtracting it. And then we combine the like terms. So that goes away. 20 minus 8 is 12. 28 take away 32 is negative 4. Bring down the 7 and repeat. So how many times does 3x squared go into 12x squared? 4 times. Multiply the 4 by your dividend. It's going to be 12x squared minus 4x minus 16. Subtract. Combine. And in this case I'm left with 9, and that's my remainder. As soon as you have no other terms that you can bring down, then you're done. Now how we write our answer is you write this first. Then you put plus, then you put your remainder, and then you put your divisor. Okay. Let's go ahead and move on to number 5. I'll leave number 4 for you. Number 5 is a synthetic division problem. It's a faster way to do division. It's like long division though, in that you got to make sure that all your terms are there. So notice that we have 5, 4, 3, 2, 1. So I'm not missing any powers there, so I don't have to put any zeros in this time. But what we do put in here is our coefficients of 8, 11, 11, 14, negative 3, and negative 20. And then we're going to put this number out in the front here, but with an opposite sign. And then we're going to follow through with a very repetitive pattern of adding down, multiplying, putting the answer there, and adding down. And when you're all done with that pattern, this number here represents your remainder, and then the divisor goes underneath of it. So x plus 1 is going to go underneath of that. This number here represents your constant. This number here represents your term with an x. This one here represents your term with an x squared, and so on. Okay, and there's our final answer. And that is synthetic division. And I will leave number 6 for you guys. Let's move on to number 8. List the possible rational roots. Now we only want to do the possible roots on this. I'm not going to ask you to find the actual roots here, just the possible ones. So to do that, we're going to start by listing our factors of the last term. So what are the numbers that go into the last term? 10 in other words. Well, 1 goes into 10, 2 goes into 10, came off, 5 goes into 10, and 10 goes into 10, and that's all the factors of 10. Now we want to list all the factors of our first coefficient. 16 can be divided by 1, 2, 4, 8, and 16. Now what we're going to do is we're going to make as many fractions as we can where these numbers are numerators and these numbers are denominators. So we want to mix together as many combos as we can. So I'm just going to start with the 1 here, and I'm going to do 1 over 1 is 1, 1 over 2 is 2, 1 over 2 is 1/2, sorry. 1 over 4 is 1/4, 1 over 8 is 1/8, and 1 over 16 is 1/16. Then you repeat that process with the 2. So now I'm going to do 2 over 1. There's a different color there. 2 over 1 is 2. 2 over 2 is 1. Now I already have a 1, so I don't need to write that one again. 2 over 2 is a half. 2 over 4 is a half, which I already have, so I don't need to write that one again. 2 over 8 is a fourth, already got it. And 2 over 16 is an eighth, already got it. And we just keep doing that for all of them. So now I'm going to do 5 over 1, 5 over 2, 5 over 4, 5 over 8, and 5 over 16. And then last we'll do the 10. 10 over 1 is 2. 10 over 2 is 5, which I already have. 10 over 4 is 5/2, which I already have. 10 over 8 is 5/4, which I already have. And 10 over 16 is 5/8, which I already have. And then all of these could be positives or negatives. So this one has quite a number of possible roots. Those are all the possible rational roots of this polynomial. They're not all roots. In fact, it's possible none of them are. But these are my possibilities. All right, so I'm going to leave you guys to do number 9. Number 9 is pretty similar to that. And actually, I'm going to let you guys do 7 because I did number 8, my bad. All right, I'm going to do number 9 here. Let's do number 9. Number 9. Given the polynomial, I'm telling you some of the possible roots. I'm not telling you all of them. And your job is going to be to figure out which of these 3 possible roots are actual roots. So basically, you need to take your polynomial and you're going to plug in each one of these numbers that I give you. So I'll start off with -1. And you're just going to repeat that for all the other numbers I gave you. So we're plugging in 5, and we're plugging in -5. And at this point, you're just going to want to use a calculator, and you're going to want to see which one of these things give you a 0. Whichever one of these possible roots actually end up giving you a 0, those are the ones that are actual roots. So let me see. In this case, this one will give you a 0. So that means that x equals 1 is an actual root. This one here will not make 0. I already know that. I can tell that because if you just look at the numbers here, this is going to be a huge number, and this is going to be a huge number, and we're just subtracting these 2 small numbers from it. So you're going to end up with a big number. It's not going to be 0. The next one might work, but I don't think so. Let's see. When you're simplifying these, you want to do the power first. So that would be 125. Then you want to do your multiplication. And I'm pretty sure this isn't going to make 0. If you were to combine these two, that's going to drop us down up to a negative 500, I believe. And then if we take 25 away from it, and if we take 5 away from it, actually this was supposed to be a negative 5, my bad, so this is plus. But you guys can see that if you add 25 to 500, then minus 5, you're not going to end up with 0. So this is not a 0 either. Okay, so on this one, only the negative 1 was an actual root. So 7 and 8 is where you find possible roots. 9 is where you plug them in and you find out which one are actual roots. Okay, so let's go ahead and move on. I'm going to let you guys handle 10, and I will do number 11 now. Number 11 says, suppose that x equals 4 is a root of the polynomial. What is a factor of that polynomial? Well, this is what we call the factor theorem. And according to the factor theorem, if you know a root, then all you have to do is put that root right here, and voila, you've got a factor. It's that simple. We're done with number 11. All right, I'll leave 12 for you guys. Let's do number 13. Describe the end behavior of the polynomial using limit notation. So when we're trying to find end behavior of a polynomial, we pay attention to the term that has the greatest power. And then I gave you guys a little chart in lesson 6.6 where we asked ourselves, is my coefficient positive or is my coefficient negative? And is my exponent even or is my exponent odd? Okay. On this problem, I've got a positive coefficient with an even exponent. And on that chart, I had pictures. And so that was the picture that was in the box for an even exponent with a positive coefficient. Now, that's what the picture would look like. That's what the graph looks like. But they want us to describe this end behavior using limit notation. So limit notation looks like this. You're going to have 2 blanks to fill in, one underneath the limit and one over here. And we're going to do that for both sides. Now, let's start off with the one over here on the right. When you're looking at the right side of your graph, that's when x is approaching positive infinity. And so over here, this one would be x is approaching negative infinity because that's the left side of my graph. What goes in the other boxes? Well, these boxes tell us whether the graph is going up or down. Positive infinity is up, negative infinity is down. So in this case, my graph is pointing upwards. So that's going to be a positive infinity. And the same thing is happening over here on the left. We're also going up on this side. So, and that's what we call end behavior. And all this stuff is telling us is that as on the left side of my graph goes up, and on the right side of my graph also goes up. It's just a way to describe what happens on the extreme left and right sides of your graph. So I'm going to let you guys handle number 14, and I'll move on to number 15. Number 15 is asking us to find the y-intercept of the polynomial. If you ever want to find a y-intercept, all you need to do is plug 0 in for x, and that works for every kind of function that's out there, actually. So all you have to do is plug 0 in for x. And after that, there's really not a whole lot of work you do because, I mean, this is going to be 0. When you multiply that times 5, you're going to get 0. So we just end up with a whole bunch of zeros in this case, and we add them all up to get 0. So my y-intercept would be at 0 for the x, because that's what I plugged in, and 0 for the y, which is what I got as a result of that. So the y-intercept would be at the origin 0, 0. So knowing that, I'll let you guys handle number 16. Let's go ahead and do number 17. On number 17, I'm asking you to find the roots. The roots are also known as the x-intercepts, or they're also known as the zeros. And the reason for that is because when you're looking at x-intercepts, that's where your graph touches the x-axis. And when your graph is touching the x-axis, the y value is 0. So the first thing we're going to do is we're going to set this whole thing equal to 0. That's how you find roots. The next thing we're going to do is we're going to do something called the zero product property. The zero product property tells us that if you have something times something times something or whatever, anytime you're multiplying two or more things together and the answer is 0, one of those things you're multiplying has to equal 0. That's the only way multiplication can ever give us 0. So that means that either 3x equals 0, x plus 2 equals 0, x minus 3 equals 0, or x plus 3 equals 0. And then all you do at that point is you solve all these equations. So for the first one here, if I divide both sides by -3, I would end up with x equals 0. On this one, if I minus 2 on both sides, I would end up with x equals -2. For this one, if you added 3 on both sides, you would get a positive 3. And for the last one here, if you minus 3 on both sides, you're going to get -3. And those are my zeros, also known as the x-intercepts, also known as the roots. All right, let's go ahead and move on. I'm going to let you guys handle actually, I'm going to do number 18 because it's a new question. Number 18 is asking us which of the roots from question 17 would bounce off of the x-axis. So as you might recall, this one gave me a root of 0, this one gave me a root of -2, this one gave me a root of 3, and this one gave me a root of -3. And all of these are places where it touches the x-axis. 0, -2, -3, and +3. But some of these roots, for some of these roots, it will bounce off of the x-axis. And that's going to happen anytime there's a power that is an even number. So since that's a power of 2, that's an even number, that means my graph will bounce off of this root right here. Now, I don't know what it looks like at this point, but just as a quick example of what it could possibly be, it might look like this, for instance, bounce. So it can either go through the x-axis or bounce off of the x-axis. But you guys don't need to know all that for the problem. Really, all you need to know is that the one that has an even power is the root that bounces off the x-axis. So the answer for this would be x equals -2 is the root that will bounce off the x-axis. So I'm going to let you guys do numbers 19 and 20. And I'm going to go ahead and do number 21 now. Now, number 21 is a similar question, but something a little different happens towards the last half of it. So we start by putting 0 in for y, because we still want to find those roots. And so we set x minus 4 equal to 0. We set x plus 5 equal to 0. And now this is a funny one here. We're going to set this equal to 0. Now in this case, if you could, you would factor this. But I'm telling you right now that's not going to factor. So how do we solve that one? That's really the issue. We already know that we're just going to solve that by adding 4 on both sides. So we're going to get 4. And we're going to solve this one by subtracting 5 on both sides. So we're going to get -5. But this guy's a little bit different. For that one, since we can't factor it, the only way to solve it is with the quadratic formula. So we're going to do x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So, pretty useful little formula. Not exactly the funnest thing in the world, but very useful. So we have 4 plus 24 over 2. And as you guys know, we need to simplify that. So when you break down 28, you get 4 times 7, which is 2 times 2 times 7. And you can take a 2 out. And so now we have, well, actually I'll put my answer down here. And then of course we reduce these three numbers if they all have something in common that can be divided out of them, and also if all three are actually present, and they are. So we can divide all three of these by 2, and we end up with our final answer of -1 plus or minus the square root of 7. There's actually 4 roots here. We have 4, -5, and then this is actually 2 answers. -1 plus the square root of 7, and also -1 minus the square root of 7. And so those are my roots. So the point of this exercise was to show you guys, well, if you get to a quadratic that can't be factored, the way you're going to solve it is with the quadratic formula. Okay, let's go ahead and keep chugging along there. I will be leaving 23 for you guys, I think. Or actually, looks like I didn't give you guys one like that, did I? Oh, I did 21. You guys are going to do 22. Awesome. All right. This one says, below you're given the equation of a polynomial in standard form, but I go ahead and I factor it for you. And what I ask you to do at that point is I ask you to graph it. Okay, so let's go ahead and do this. So the reason I gave it to you in both forms is because you need this one to find the end behavior, but you need this one to find the roots. And we need both of those things to graph it. Now I could have asked you guys to factor it, but on your test, most of the questions I give you of this sort will be factored just because the factoring step does take so long. So since we have a lot of other questions that ask about factoring, for this one I'm just going to give it to you in factored form. So there it is. It's in factored form. So what do we do first then? Well, the first thing that we're going to do is we're going to find our roots. And you do that by setting each one of these factors equal to 0 like we did in the previous example. So if you set that one equal to 0 and solve, you get 0. If you set this one equal to 0 and solve, you get 1. If you set this one equal to 0 and solve, you'll get -1. And if you set x plus 3 equal to 0 and solve, you'll get -3. So I've got 4 different roots there. The next thing you're going to do is you're going to identify which ones will bounce off of the x-axis. Well, we talked about that earlier as well. Any of the factors that have an even multiplicity or an even power will be factors that bounce. The other ones will go through the x-axis. So I'm going to put T for through and B for bounce. And the ones that have an even power are the roots that will bounce off of the x-axis. The next thing you're going to want to do is you're going to want to find the y-intercept. And the y-intercept, as we mentioned earlier in the lesson, is found by plugging 0 in for x to your original equation. So I guess we need the original one to find the y-intercept also, as well as the end behavior, right? All right, well, if I plug 0 in here, since they all have an x, everything's going to become 0. So in that case, I'm just going to have 0. But if you have a number after this, like let's say it was plus 5, at the very end with no x, well, that number 5 would actually be your y-intercept. But since I don't have one there, mine's just going to be 0. So that's my y-intercept. And then the final thing we need to find is we need to find our end behavior. Now, as you guys know, when you're doing this, you look at the first term, or the term that has the power that is highest. For this particular problem, that's -x to the 5th. And as we mentioned on an earlier problem, when you have an odd power with a negative coefficient, it's up on the left and down on the right. And that would be my end behavior. Okay. Now I don't need to describe this with limit notation, although we could do that here. But since we're graphing, I just need to know what the ends of the graph look like. I don't need to describe it with limit notation. So now we're ready to graph. We're just going to start plotting stuff up. So let's do our roots first. We have 0, 1, -1, and -3. And we want to remember that -3 was the one that bounces, and the rest of these, the graph will go through the x-axis. The next thing we want to do is we want to identify our y-intercept, and in this case my y-intercept is 0, so that's just going to be the same thing as one of my roots. But it's not always a root, so don't get too comfortable with it. In this case, the y-intercept is a root. And then finally we have the last part, which is the end behavior. So I know it needs to go up on the left and down on the right. And then I'm just going to connect all this information together the way that it should. So I know that this arrow should be on the left, and then it should bounce off of this root, and then it should go through this root, through this root, through that root, and connect to that arrow on the right. And that'll be good enough for us. Okay? And that's graphing a polynomial in factored form. And I'll be leaving number 24 for you guys to do. All right, last problem we'll be looking at here together is number 25. On this one, we're going to be asked to factor it, and I give you one of the roots, and that's going to be your beginning point. So the first thing to do is we're going to identify, okay, there's my root. The first thing we're going to do is identify the factor. Using the factor theorem, that means that the factor that goes with that root is x plus 5. And so what I want to do now is I want to divide my polynomial by x plus 5. Now, when we do this, we're going to be able to do synthetic division because this is in the proper format for that, and with these problems it will turn out that way every time. So, we put the opposite of this number here, and then we put all the coefficients in. You've got to make sure that all your terms are accounted for. I've got 4, 3, 2, 1, and none, so that's good. But don't forget, if you're ever missing a term, you do need to put a 0 in as a placeholder. And let's go ahead and do our long division here. You should always get 0 here at this step because we're dividing a polynomial by one of its factors. And when you divide a polynomial by its factor, the remainder should be 0. So now as a result, I've got my remainder is 0. This is my constant. This is my x, x squared, and x cubed. So I have my factor that I created in step A. And we have this new polynomial that we just created by doing the synthetic division. And now we're going to continue factoring using our old school factoring strategies. Okay. So this thing here has no GCF. So we could skip that step, but we will move on now to the step of doing the box method because there are 4 terms. First term there, last term there. The other 2 terms go in the box in the other places there. And we take out what they have in common. These 2 have a 3x squared in common. These 2 have a 4 in common. These 2 have an x in common. And these 2 have a 3 in common. And so we have x plus 5, 3x squared plus 4, and x plus 3. And then we should probably see if any of these things can be factored anymore. These are these are binomials with the highest power of 1. Those are done. This guy here, the only thing it could be because it has 2 terms is the difference of squares, but it's not. And so this would be the final answer there. Okay? So step 1 is to turn the root into a factor. Step 2 is to do synthetic division. And then from there, you use the factoring strategies that we talked about in 6.2. All right, and that'll do it.